The RIM-116 Rolling Airframe Missile, or RAM, refers to a lightweight, quick-reaction, fire-and-forget missile. It was designed to destroy anti-ship cruise missiles and asymmetric air and surface threats. The RIM-116 was developed as a collaboration project between the U.S. and German governments and continues to be cooperatively produced and supported. Currently, there are two RIM-116 configurations, namely Block 1A, RIM-116B, and Block 2, RIM-116C. Block 1A is nearly finished with full-rate production. Meanwhile, the RAM Block 2 configuration is currently in low-rate initial production and undergoing developmental and operational testing. In regard to the development, the RIM-116 was developed by General Dynamics Pomona and Valley Systems divisions under a July 1976 agreement with Denmark and West Germany. The General Dynamics Missile Company, which is today part of Raytheon. At that time, Denmark withdrew from the program while the U.S. Navy joined in as the major partner. The Mark 49 launcher was evaluated on board the destroyer U.S. David R. Ray in the late 1980s. The first 30 missiles were manufactured in FI 1985 and went into service on 14 November 1992 on board U.S. Palilio. If we take a closer look at the features, the RIM-116 RAM is designed as a high-firepower, low-cost, self-defense system against anti-ship cruise missiles and other asymmetric threats. The original Block 0 design was based upon the infrared seeker of the Stinger missile and the warhead, rocket motor and fuse from the Sidewinder missile. The Block 0 configuration provided radio frequency for mid-course guidance and transitions to infrared guidance for terminal engagement. Also, no shipboard support needed after missile launch. The Block 1A incorporates the added capability of autonomous infrared all-the-way guidance, thus countering advanced anti-ship cruise missiles that do not employ onboard radar seekers. Furthermore, the Block 2 provides kinematic and guidance improvements to the missile for countering maneuvering threats and regaining battle space. It features a control section upgrade, 4 canards versus current 2, a propulsion section upgrade, which is a larger composite case rocket motor, and an evolved radio frequency receiver. RAM Block 2 initial operating capability was achieved in May 2015. Approval for full-rate production was received in November 2018. Moving on to the following scene, we'll identify where actually this missile commonly installed. The Rolling Airframe Missiles is deployed worldwide via the Mark 49 RAM Guided Missile Launching System and the Mark 15 Mod 32C RAM Close-in Weapon System (CWES) on more than 100 ships. It ranges from fast patrol boats to aircraft carriers and is being installed on a majority of new USN ship classes such as LHA-6, CVN-78, and FFG. The RIM-116 is also deployed on the LCS ship class utilizing Mark 15 Mod 31 Serum, CWIS, and DDG-64, 71, 75, 78, utilizing Mark 15 Mod 33 Serum, CWIS. The RIM-116 is fully in service with the U.S., German, and Allied navies including South Korea, Greece, Egypt, United Arab Emirates, Turkey, and Japan, with approximately 5,000 missiles produced throughout the life of the program. As its name indicates, RAM rolls as it flies. The missile needs to roll during flight because the RF tracking system uses a 2-antenna interferometer to measure phase interference of the electromagnetic wave in one plane only. The rolling interferometer allows the antennas to look at all planes of incoming energy. In addition, because the missile rolls, only one pair of steering canards is required. As of 2005, it is the only U.S. Navy missile to operate in this method. Talking about its service history, the RIM-116 has been in operation since 1992 until present, especially on several American and 30 German warships. All new German Navy warships is equipped with the RAM, such as the new Braunschweig-class corvettes, which will mount to 2 RAM launchers per ship. The Greek Navy has also equipped the new Super Vita-class fast attack craft with the RAM. South Korea has agreed the licensed production contracts for their Navy's KDX-2, KDX-3, and Dokdo-class amphibious assault ship. Moving on further, we will identify some variants of this missile, including, first, the Block 0, which is the original version of the missile. It was based on the AIM-9 Sidewinder air-to-air missile, whose rocket motor, fuse, and warhead were used. Block 0 missiles were built to initially home in on radiation emitted from a target, such as the active radar of an incoming anti-ship missile, switching to an infrared seeker derived from that of the FIM-92 Stinger missile for terminal guidance. In test firings, the Block 0 missiles achieved hit rates of over 95%. Moreover, the Block 1, which is known as RIM-116B, is a more advanced variant of the RAM missile that adds an overall infrared-only guidance system that allows it to intercept missiles that are not emitting any radar signals. The Block 0's radar homing capabilities have been retained. Followed by the Block 2 variant. It is an upgraded version of the RAM missile aimed at more effectively countering more maneuverable anti-ship missiles. On 8 May 2007, the U.S. Navy granted Raytheon Missile Systems a $105 million development contract, which was expected to be completed by December 2010. LRIP began in 2012. 51 missiles were initially requested. On 22 October 2012, the RAM Block 2 completed its third guided test vehicle flight, firing 2 missiles in a salvo and directly striking the target. This test is intended to evaluate the system's command and control capabilities, kinematic performance, guidance system, and airframe capabilities. Moreover, Raytheon was expected to deliver 25 of Block 2 missiles during the program's integrated testing phase. The Block 2 RAM was delivered to the U.S. Navy in August 2014, with precisely 502 missiles to be acquired from 2015 to 2019. Initial operational capability for the Block 2 RAM was achieved on 15 May 2015. The next one is HAAS mode. In 1998, a Memorandum of Understanding was signed by the Defense Departments of Germany and the United States to enhance the system, so that it could also engage the so-called HAAS, helicopter, aircraft, and surface targets. As developed, the HAAS upgrade just required software modifications that can be deployed to all Block 1 RAM missiles. The last one is Serum Weapon System. The Serum combines the radar and electro-optical system of the Phalanx C-Wismark 15 Block 1B with an 11-cell RAM launcher to create an autonomous system, one which does not need any external information to engage threats. Similar to the Phalanx, Serum can be installed to any class of ship. The first Serum system was delivered in 2008 to be installed on U.S. Independence. As of December 2013, one Serum is fitted to each Independence-class vessel. Moreover, the Navy announced in late 2014 that the Serum would be installed on the small surface combatant LCS follow-on ships. Beginning in November 2015, the Navy will complete installation of a Serum on the first of 4 Arleigh Burke-class destroyers patrolling within the U.S. Sixth Fleet. In addition, the Serum will also equip the Royal Saudi Navy's multi-mission surface combat based on the Freedom-class littoral combat ships. In relation to the U.S. Navy, they are purchasing a total of 1,600 RAMs and 115 launchers to equip 74 ships. According to Raytheon updates, the average price of this missile can reach up to $998,000 in FY 2014 or $905,330 in FY 2021. This missile is also currently active aboard on several ships, including Gerald R. Ford-class, Nimitz-class, Wasp-class amphibious assault ships, San Antonio-class amphibious transport dock ships, Whidbey Island-class dock landing ship, Harper's Ferry-class dock landing ships, and littoral combat ships, to name a few. That's all for today. Thanks for watching, and see you next time.